Hello everybody and welcome to Brain Linker. In the previous video, we had discussed couple of object relational mismatches. In this video, we will continue with that topic and we'll learn next couple of mismatches and we'll discuss fifth one in the next video. Let's start with third mismatch, problem of identity. In Java, whenever we want to check whether two instances or objects are identical or not, then we can do it in two ways. First one, instance identity, means using double equals to a equals to b, where a and b both are objects. Second way is instance equality, means using equals method, a dot equals b, where again a and b both are objects. In RDBMS, we have only one way to identify row is using primary key, which is neither equivalent to double equals to nor equivalent to equals method. Another thing in RDBMS, continuing with our earlier example, I have directly taken ID column as primary key, but suppose we alter or change table definition, we remove ID column and make first name as primary key. Let's take a scenario. Suppose I have mistakenly written my first name in last name column and my last name in first name column of customers table, and then suppose there is a table known as orders used to store all the details of customers order. That's why it uses customer's first name as foreign key. I think you all are aware of foreign key. Foreign key is primary key of another table and used to establish links between tables. That's why this first row of orders table specifies that customer Radhanpura has ordered product number 04. This product ID is also a foreign key of some products table. You can assume that. Now back to our example. In order to rectify the mistake of wrong first name, we have to change appropriate row in first name column of customers table. Let's do it. Then we have to change appropriate row in all the tables where first name is used as foreign key. As you can see, we rectified our mistakes. Due to the problem of multiple changes, generally surrogate keys are used, means ID column that we have used. It contains system generated values. For example, for first row, its value is 1. For second row, its value is 2, and so on. Its value doesn't depend on Java side. Its sole purpose is to provide uniqueness to row. We can use this ID as foreign key as well. And if we want to change first name, then we have to change here only. We don't have to change anywhere else. That's the main advantage of surrogate keys. Hence the problem is how can we represent these surrogate values on Java side. That's all in problem of identity. Fourth mismatch, problem relating to association. Association means relationship between entities. In order to reflect an association in Java, we use object references. In simpler terms, we make object of one class as data member of the second class. Let's make it more clear by an example. To indicate every customer has an address, we can make an address object as data member of customers class. That indicates the relationship between customers and address class. This object relation is directional, means we can navigate to address from customers class because we have object of address as data member of customers class, and using this object we can access properties of address class. But we cannot navigate from address to customers because we don't have object of customers class as data member of address class. While on RDBMS side, foreign key is used to reflect an association. Navigation in particular direction has no meaning to RDBMS because we can make any arbitrary association using SQL joins. Another thing is we can represent many-to-many relationship on Java side. Let's take an example of book and author. A book may have more than one author and an author may have written many books. That's a many-to-many relationship. We can represent it like these. Set of authors object as data member of books class and set of books object as data member of authors class. But on RDBMS side, we cannot represent many-to-many relationship directly, because if we make table for books class, it will look like these. As you can see, there is only one column for author name, so we can accommodate books having one author. But what about books having multiple authors? Suppose a book has two authors. In that case, we have to write one author's name and simply ignore others that we cannot afford. One solution you might think is add another column. If we add another column, then we can accommodate books that has two authors. But again, question remains, how can we accommodate books that has three authors? Another problem is book that has only one author will contain null values for remaining author fields. Similar problem for authors table as well. Here comes the solution part. Using a mapping table, or I can say link table, we can represent many-to-many relationship. Let's see how. First of all, we make changes in table schema of both the tables. Now books table contains book ID and book name, and authors table contains author ID and author name. Book ID is primary key for books table, and author ID is primary key for authors table. Here comes the mapping table. Here, book author ID is primary key, and book ID and author ID both are foreign keys. As you can see, book 1 or book ID 1 has two authors. That's why there are two entries or rows for book 1, one for author 1 and second one is for author 2. Book 2 has only one author. That's why a single entry for book 2. Suppose a book has three authors, then there are three entries for that book. So the problem is, how can we represent these linked tables on Java side? That's all for problem relating to association. That's it for today's video. If you like this video, then please press the like button. Hit the subscribe button to join our collection. You can give your feedback or doubt in comment section. Goodbye.